Now let us see 21st question in the arches. You have a symmetrical two-hinged parabolic arch rib. This is the two-hinged parabolic arch, has a span of 32 meters. Between the abutment pins at the same level and central rise 5 meters. Height is 5 meters. The second moment of area of the rib varies as the secant of angle of inclination I is equal to I0 into secant theta. When a rolling load of 100 kilonewton crosses the span, the maximum horizontal thrust. We know that the rolling load must be at the crown, 100 kilonewton. Then what is the horizontal thrust? This horizontal thrust, we have known the formula. When a central point load is moving, ILD if you draw, the ILD will go parabolically, a fourth degree curve. This is 25 L by 128 H. So W horizontal thrust formula is WL by W into, or we can say 25 WL by 128 H. This is the standard formula for that, whose ILD is like this. ILD for horizontal thrust. This is a fourth degree curve I told you earlier. Fourth degree parabola. Okay, so 25, W is 100, length is 32 by 128 into height is 5. 32 means 16 you will get 4 fours. Okay, 5 into 5, 25, 4, 25. So you will get 125 kilonewton. So you will get around 125 kilonewton. So 21 B is the option. Next 22. A three-hinged arch shown in the above figure. The influence line for horizontal thrust, we know that central height is L by 4H. So C is the option. 23rd one. A uniformly distributed, shorter than the span, crosses three-hinged arch from left to right. We have a three-hinged arch. Okay, some UDL shorter than the span, moving from left to right. For maximum horizontal thrust, I told you, if you have the L by 4H, this one like this say. UDL shorter than the span means left half and right half. That means whatever way the C cuts the span, it should cut the load also, because it is symmetrical to the, it is similar to your bend moment diagram, ILD for bend moment at C. Okay, so similar to that was there. Now let us see what is the option. For maximum horizontal thrust, which one of the following statements indicates the position of the load? Rear end of load at left support, wrong. Front end of load at central hinge, wrong. Load positioned in such a way that the central hinge divides the load symmetrically into two halves. So C is the correct one. Load positioned in such a way that the central hinge divides the load so that center of the load and rear end of the load are equidistant from center. That is also wrong. So it must be like this. Whatever way the central hinge divides the load symmetrically into two halves. Okay. So this is what I have given you already. If a point load is there, it should be at center. Whatever rules are available for the ILD for bend moment at C, same rules are available for maximum horizontal thrust also. But it's because it is similar to ILD for bending moment at C. Only thing is divided by H extra is there. So if 4 or 5 point loads are moving, I gave you average load on AC is equal to average load on CB. So to get maximum H, average load on AC must be equal to average load on BC. That means half the load here, half the load right side. So correct option is C. Next, 24. Influence line, you see it's a fourth degree curve already, I told you. It's solved in the class also. Then 25, a 3-hinged parabolic arch span 20 meters. We have a 3-hinged parabolic arch. Three-hinged parabolic arch. ABC span 20 meters. ABC, the span is 20 meters. Central rise 4 meters. Arch has hinges at the ends and at center. Okay. A train of 2-point loads 20, 10, 5 meters apart crosses the arch from left to right with 20 kN load leading. Maximum horizontal thrust induced at the supports. So L by 4H is the formula. This is ILD for horizontal thrust. What is the height here? L by 4H. L is 20 meters by 4 into H is 4. So 20 by 16 means 5 by 4. That means 1.25. So this height here is 1.25. Okay. Now this is 10 meters. So to get maximum horizontal thrust, greater load here. That means greater load is 20 kilonewton. And let it come here. Then 5 kilonewton you keep it here. Space between them is 5 meters apart. So how much? This is 10 meters. For 10 meters 1.25. 5 meters, remaining height is now 5 meters only up to here. Then this height must be 1.25 by 2. Now you see what is maximum horizontal thrust? 20 into 1.25 plus 5 into 1.25 by 2. So we can write it as 1.25 if you take common factor out. This is 20 plus, that means you will get around 22.5. So you will get now 22.5 plus 1/4 of that. So you will get around 1/4 means approximately 5. 22 plus 5. So approximately answer is B. So 25th one is B. You will get around 28.13. So 22.5 into 1 by 4 means you will get around by 4. .6 like that. So 22.5, then 5.6. So 28 point something. So correct. So calculators are not required. 25th question is B. 28.13. Then 26th. Horizontal thrust at support A in a 3-hinged arch shown in figure. Horizontal thrust. Then hinge is not at somewhere here, it is there. A, B, C. The difference in elevation also is there, 1 meter. So 1 meter is the difference. Hinge is here, UDL here, 1 kilonewton per meter. Then 1 meter level difference. Total height is 5 meters. From here to here 5 meters. Here to here 4 meters. And the remaining length is 1 meter. Like that he has given. This is 8 meters. And this is 10 meters. Such cases, if the supports are at different level, you have to calculate VA, VB, etc. He is asking what is the horizontal thrust. So first you can find VA, take moments of all force about B equal to 0. So you will get moments of all force about B plus VA, this is VA here, HA here. So plus VA into 18 plus HA into 1 minus 1 into 8 into, so 10 plus 4, 14, must be 0. So 18 VA plus HA is equal to 14 into 8, 112. Then bending moment at C is equal to 0. If I take that, plus VA into 8 minus HA into 4 minus 1 into 8 into 4 is equal to 0. So 8 VA minus 4 HA is equal to 32. So divided by 4. So 2 VA minus HA is equal to 8. So you will get 2 VA minus HA is equal to 8. So two equations, when you solve it, cut it, 18 plus 2, 20 VA is equal to 120. So VA you will get 6. Then HA is, you will get 2 VA minus 8, you can write 2 VA minus 8, 2 into 6, 12 minus 8. So HA you will get 4 kilonewton. So 26th one, B is the answer. There we cannot use ILD because two supports are at different location. Next, 27. Now see, consider the following statements with respect to arches. Normal thrust at any section of the arch is the component of interacting forces on the section acting along tangent to the central line of the arch. That is correct. Then radial shear, this question we have solved it already. This one is similar to the third question. Third and this and 27 same. 1, 2, 3 are correct. Then 28, it is repetition. 28, a two-hinged arch shown in figure, which one of the following diagrams represents the shape of the bending moment variation? Shape of the bending moment variation means wherever you apply load it will sag, the other end will hog. So load application point, it should be sagging bending moment. Without the load beam, arch will hog, so negative bending moment should be there. You see here B option, A to center there was a positive bending moment, then there is a point of contraflexure and negative bending moment it came. That's all. B is the option. Where you are pressing it will sag, positive bending moment. Where you are not pressing it will hog. So it goes up, that's all. No great thinking is required for that. Okay. 29. A three-hinged arch shown in figure is a quarter of a circle. This I think in the GATE we have this already solved. GATE question paper, it was already given. There was some hinge here. So radius of the circle is R. Then this is some origin O, let us say. This is making an angle theta. You are applying load P. Okay. A, this point is A, this point is C. Three-hinged arch, this is three-hinged arch only now. This point is B. shown in figure is quarter of a circle. The vertical load and horizontal components of the reaction at A are equal. HA, VA are equal. The value of theta. If VA and HA are to be equal, then what will happen is theta will not be in this range. When you calculate it, you will get the absurd values, negative values you will get for theta. So none in theta and 90 degrees, none in 0 degrees, 90 degrees, because you will get theta value beyond this range when you are calculating the values. You take moments about all force about C is equal to 0, say. Okay. So this explanation is already given in the GATE 2021 booklet. Okay. Already it was solved. Find the reactions, then find what should be the theta to get VA and HA to be equal. Then theta will get not in the 0 to 90 degrees. Okay. Then 30. The absolute maximum bending moment due to a single rolling load in a 3-hinged parabolic arch central rise H having one of its hinges at the crown occurs at a distance x from either support. The value of x is given by, this I have given you earlier, absolute maximum bending moment x is equal to 0.211 L. 0.211 L if I want to get it, which answer will tally? L by 2 root 3, L by 3 plus root 3 if you take it. So, if you take this value, just 1 minute. Okay, I have given you 0.211 L, then this can be written as L by 3 plus root 3, also same thing. So 30th question, D is the option. 3 plus root 3, 1 by 3 plus root 3 or 0.211 L, which we have solved it, same. So 30th question is over. Next, 31. Which one of the following is associated with the rib shortening in arches? This also same question is repeated. Only 2-hinged arches and not 3-hinged arches, because 3-hinged arches due to rib shortening will not happen, because no temperature rise or sinking or yielding or fabrication errors will not produce any stresses. Okay. So over. Next, 32. A 3-hinged circular arch ACB is formed by two quadrants of circles AC and BC of radii 2r and r respectively. So it is like this. One is R. This is a 3-hinged one. Another is only smaller one. Like this. Radius R. This is 2r. Then you have at the center crown there is a point load W. As shown in, consider the following in respect of the reactive forces developed at supports A and B due to concentrated load at the crown. So due to this load there are two reactions VA, HA. This point let us say B, VB, HB. Okay. Now this distance is R, this distance is also R. Okay, this point. Now you have to find line of action of RA is inclined at 45 degrees to the horizontal. Let us first find, take moments of all force about B is equal to 0. Sigma MB is equal to 0. So plus VA into 3R Clockwise, this is minus HA into R. This is also minus W into R is equal to 0. So 3VA minus HA is equal to W. Then bending moment at C is equal to 0. So you will get plus VA into 2R minus HA into 2R. So you will get VA is equal to HA. That means what? Reaction is at this RA, let us say. It is inclined at an angle of 45 degrees because HA is nothing but VA. So first statement, line of action of RA at A is inclined at 45 degrees with horizontal. So first statement is correct. First statement is correct because VA is equal to HA, we got it. Then VA is equal to VB is equal to W by 2. VA is equal to HA if you substitute 2 in 1. So 3VA minus HA means VA is equal to W. So 2VA is equal to W. So VA is equal to W by 2. So HA is also W by 2. So VA is equal to VB is equal to W by 2. Second statement also correct. First is correct. Third one, VB is equal, HB is equal to 2HA. Cannot be correct. Third statement is wrong. HB cannot be equal to 2HA because HA and HB must be same. So third statement is wrong. HA and HB is equal to W by 2. Fourth statement is correct. So which of the above are correct? C. 1, 2, 4 are correct. Okay. Third statement is wrong. Simple question, just find the reactions and observe the statements. Next, third question. A parabolic arch symmetrical with hinges at center and at ends, that means is a 3-hinged arch, carries a point load W at x, distance of x from left support. So this distance is x, the remaining is L minus x. The arch has a span of 20 meters. Okay, this is 20 meters and rise of 5 meters. So this is 5 meters. What is the value of x? Value of x if the left hinge reaction is inclined with a slope of 2 vertical on 1 horizontal. 2 vertical, 1 horizontal. HA, 2VA. So now if I take reaction RA, it's like this. HA, 2VA, 1 horizontal, 2 vertical, means now the slope is 2:1. That means the resultant reaction must have so much slope. 2 vertical, 1 horizontal means like this. Vertical reaction 2VA, horizontal reaction is HA. Then the resultant reaction, square root of this one, it will have an inclination of same thing, 2VA is equal to HA. That means this must be VA. HA is equal to VA. If HA is VA, this is 2VA. So 2:1. If the horizontal 1, vertical 2, 1, 2. So RA. For that to happen, what is the value of x? What should be the x now? Again same thing, reactions. This is VB, sum HB. Take moments of all force about B is equal to 0. Sigma MB is equal to 0. So vertical reaction is 2VA now. If I take this as 2VA into 20 meters clockwise minus W into 20 minus x must be equal to 0. So 40VA minus 20W plus WX is equal to 0. Call it as equation 1. Next, bending moment at crown is equal to 0. Bending moment at C is equal to 0. How much you will get? Plus 2VA into 10 minus VA into 5 minus W into 10 minus X must be 0. So 20 VA, 20 minus 5, 15 VA goes to the right side, 10 W plus means minus, you will get minus WX. This is 40 VA. 40 VA is equal to 20 W minus WX. Okay. So now VA, if you substitute 1 and 2, solving 1 and 2, you will get VA and W. VA and X we can get. So this way we can write it as VA is equal to 10 W minus WX by 15. Then substitute in 140 VA, 40 into 10 W minus WX by 15 is equal to 20 W minus WX. So 80 W minus 8 WX is equal to 3 goes this side, 60 W minus 3 WX. Push it to the right side. Everywhere W common, we can remove it. 80 minus 8, 8x, 60 minus 3x. Push it to the right side. So 5x is equal to 20. So x you will get 4 meters. So 33, 4 meters. So 33C is the option. This is the if this reaction is 2VA, horizontal reaction must be VA. Then the resultant reaction will make an angle of inclination of 2 vertical to 1 horizontal. This is the core part of the problem. Once you fix that, this is again 2 simultaneous equations solving without the calculator. Now you see 34th question. We have a three-hinged arch but straight segments A, B, C. There is a vertical load of P. You take a section XX at a distance of, vertical distance of, this means projection. This is 2 meters and this is 4 meters. Height is also 4 meters. This is also 4 meters. Height is also 4 meters. It implies that this theta is 45 degrees. Okay, what is the shear force at section XX? In the free hinged, not free, it is a 3-hinged frame. 3-hinged frame shown in figure. shear force when you are calculating, it must be parallel to the cross section. For that you require what is VA and what is HA. Then you can find the components. This angle of inclination is 45 degrees. Then first find VA. Total find moments of all force about C. Sigma MC is equal to 0. So plus VA into 8 minus P into, this is theta is 45 degrees, means this is 2 meters gone. Then total is 8. So remaining length is 6 meters. Minus P into 6 is equal to 0. So VA is equal to 6P by 8. That means 3P by 4 by 0.75P. Then HA, take bending moment at B is equal to 0 plus VA into 4 minus HA into 4 minus P into 2 must be 0 because this remaining length is also 2 meters. So VA into 4. Now from this VA is 3 by 4P. So this I can take it as 3P by 4 into 4 means 3P. So 3P minus 2P, you will get P. So goes to the right side minus P. So 4HA is equal to P. This is 3P minus 2P means P minus P. So P by 4. So HA is equal to P by 4. Okay. So we have known now two reactions. Now shear force at XX. Stand at XX and look left. Okay. If you look left, two forces, VA and HA components you have to find. So VA component, if I take it, it will act, VA is like this, it will act this way. HA component will act down. Section left side upward positive, left side downward negative. So plus VA sin 45 minus HA cos 45 or sin 45, anything is okay. So VA you got it as 3 by 4, I will write it like this, 3P by 4 into sin 45 means 1 by root 2 minus HA is P by 4 into root 2. This is shear force at XX. So 4 root 2 common, 3P minus P, 2P by 4 root 2. That means P by 2 root 2. So shear force at XX is P by 2 root 2. If P by 2, I can write it as 0.5P by root 2. 0.5P by root 2. So 34C is the option. Core part is this one. Shear force on the member means you should not take vertical direction. At any section, shear force means you should be parallel to the cross section. That means XX is like this. Stand there, look left. There are two forces. Find the components of the two forces in the XX direction. Like this. That will give you the shear force at XX in the member. Next, 35. This given a circular segmental three-hinged arch of span 36 meters. Circular segmental arch. So this is the part of a circle. It's not a parabola. If you make it, you will get a circle. Arch of span 36 meters. This span is 36 meters. And rise of 6 meters. This rise is 6 meters. Hinged at the crown and springings. It carries a horizontal load of 100 newtons per meter, covering full height of the arch on left side. Full height of the arch 100 newtons per meter, like this. This value is 1000 newtons per meter. Horizontally it was acting like this. Maybe it is pushing this way. Full height of the arch on the left side. Horizontal thrust on the right springing will be, this is VB, this is HB, this is VA. HA also may be acting like this say. So loading is this way, acting here on the left end. Now say let us take moments of all forces about B. Sigma m B is equal to 0 plus VA into 36 clockwise, load also clockwise moment. So plus 1000 into 6 into total load into 6 by 2. So that is a perpendicular distance. Both of them are plus. That's all. Must be equal to 0. So VA you will get 36 cancels out minus 1000 by 2. 6 into 6 36, 36 cancels out. So 1000 by 2 means minus 500 Newton. Minus indicates that VA is acting downward. VA cannot act upward. VA must act downward. 500 Newton. Next, bending moment at, if this is 500 down, this should be 500 up. 500 Newton up. Otherwise, couple will not form. So 500 into 36 means how much is that? Around 1800. 6, 900. 1000 into 6 is the total load. So it will act like this. 6 into 6, 36. So VA is 500. So 500 into 36 means 1800. Clockwise couple is 6000 into 3. So tallied. So clockwise couple, anti-clockwise couple balances. Next, bending moment at crown. Bending moment at C is equal to 0. Stand at C and look right. Easy for us. Load you don't have to consider. Minus anti-clockwise minus 500 into 18 anti-clockwise plus HB into 6 is equal to 0. So HB you will get minus 500 into 18 by 6. 6 into 3. So anti-clockwise clockwise. So it becomes plus 1500 Newton. So HB you will get around 1500 Newton. So 35D is the option. Okay, next 36. Consider the following statements in respect of arches construction made of visors. Visors means like stones. The superimposed load is transferred to the side walls. It is like olden days, if you see, the arches are constructed with only the stones. Okay, so those stones are under, that is like a theoretical arch. Then only compression will be, the normal thrust will be there, no shear force, no bending moment. The superimposed load is transferred to the side walls only by the strength of cohesion of mortar between the visors. That is wrong. Cohesion between the visors means shear. There is no shear at all. So shear force is 0, first thing. That's why load is transferred to the side walls through the axial thrust only. So shear, first statement is wrong. It is not transferred by cohesion. Cohesion means the sticking part. It is not because of the cohesion. The arch may fail under strength of cohesion of mortar. Okay. Strength of cohesion of mortar means compressive strength of cohesion. So that's wrong. It is the compression should be there. The arch may fail under crushing when the compressive stress or thrust in it exceeds the safe crushing strength of the visor material. This is correct. Arch will fail if the visors means stones you take it, if they get crushed, then it will collapse. So because normal thrust only will exist. So second statement is correct. Every element in the arch is subjected to compression only, correct. Only thrust will be there. Failure of the arch due to the sliding of any visor past the adjacent one due to transverse shear can be avoided by reducing the height of visors due to sliding. There is no sliding at all in this one. So, failure of the arch due to sliding. In the visors theoretical arch, when you are taking, only direct compression will be there, no question of sliding. Sliding will be there if there is a shear. No shear, no bending moment. So, fourth option is wrong. So, 2 and 3 only are correct. That means D is the option. That sixth question, D. In the olden days, stone construction, when you see the forts, etc., arches, you will see. Then, if you observe there, the stones are simply stones are laid in the circular arch type. Whatever stone crushing strength is there is the strength of the arch. If the stones crush by direct compression due to axial thrust, then the arch will collapse. So, the strength of the arch is the strength of the stone itself. No shear, so no question of sliding. Okay. Then first one is by the strength of cohesion of mortar. Mortar we don't put it at all. So stone and stone direct contact will be there. Whatever gaps are there here and there, mortar will provide. Mortar strength will not matter at all. Next, 37. When we are discussing about the arches, then arch 2 hinged, 3 hinged arches you must study once again, then see the solutions. Otherwise, again everything looks new. You may feel that we don't understand. So, to have a fresh look at the questions, first you study 2 and 3 hinged arches, then solve on your own, then see the solutions. That is the process. Otherwise, simply some question, some solution, that's all. Our thinking will not be there. These workbook solutions, after you try, then only you listen to the videos. Now, let us see question number 37. Two identical parabolic arches have their outer ends hinged with inner ends. Like this is given. And here there is a hinge support. That means no reaction can develop here. These are two hinged arches connected by a common roller subjected to UDL like this. So, small w kilonewtons per meter. Okay, span is L. This is also L. Rise is H. The same identical arches. This point let us say A, B. This point let us say C. This point let us say D. Okay. Now, supposing that if this arch is not there, there is a roller only is there, let us assume. Then when you load only one span, there will be one horizontal thrust. For this case, there will be one H. Here no H, there is a H here. He is asking how much it is. Assume that for this case, this is the H. Now this roller, because when you are pressing it, down, this will sway towards right by some amount to delta. Okay, so this moves right side. For such case, when it's moving right side, h will not be WL square by 8h because it should remain there only. If it remains there only, WL square by 8h formula is valid for this span. And if it remains there only here, there will be no horizontal thrust at all. But it is not remaining. When you are applying load, when it presses down, it goes right side. But no reaction here, H and H will develop. This will B will go slightly up to here. It sways to the right side some by delta, let us say. B will go to B dash. Now assume that same thing, I load it like this, say A, this is B, this is D, hinge. I apply load only on this one. There will be one horizontal thrust here, there will be another horizontal thrust here. Because when I press it down, this point B will go towards left. Somewhere here, B will go to B dash, same amount of delta it will go. For this case also horizontal thrust is H and H. Now if I load both the spans like this, okay, this is hinge now. Now this span H, if you load this span H, both the spans if I put it, I have to write it as 2H. Here also 2H. This case we know. In this case, for 2H, 2H when they develop, because of the symmetry of loading, B will not move in any direction. B will not sway due to symmetry. Symmetry of structure and loading. But for this case, if it doesn't sway either to the right or to the left, we know how to calculate the reaction. WL square by 8H for this one, WL square by 8H. That means your 2H is WL square by 8H, this value. For this span, 2H, WL square by 8H. This 2H must be WL square by 8H. So, here one WL square by 8H will develop, this also one WL square by 8H will develop, they balance each other. Okay. Now, 2H is equal to, in this case, 2H is equal to WL square by 8H. Okay. Now, if I remove one loading, let us say, then only horizontal thrust I can get. What is H for this case? So, this is some H, this is some H. For this it is 2H. If I remove one load, I can take it as only H. So, you will get WL square by 16H. This much will develop for either this case or this case, WL square by 16H. Both you load it, 2H will become, it will become 2H, whose value is WL square by 8H. Otherwise, it's only H here. For this case, some H, we don't know how much it is because because B is moving right side. For this also we don't know because B is moving left side. It is not remaining there. But if it remains there, we know formula WL square by 8H. Now we have two spans. For one span WL square by 8H, another span WL square by 8H. Then total load we call, let us call it as a 2H, because this plus this is this one. 2H, 2H we have taken, it is not moving any direction. For this case, we want to know what is the horizontal thrust. That we know 2H must be equal to WL square by 8H, because for this span separate, for this span separate. Now only one case if one will remove one load, then 2H value is WL square by H, means H must be WL square by 16H. That case either this or this, that formula is valid. That means WL square by 16H means 37. C is the option. Okay. I remove this one. So this is from the case of when both spans are loaded, if you know, then half of that will be one span loaded value. 38th question is same as 36th one. So same answer, 2 and 3 only, D is the option. Okay, now 39th question we will see. Assertion and reasoning type. In a two-hinged arch, the shape of the Bendman diagram will correspond to the shape of the arch due to temperature rise. This what I have given you. Shape of the Bendman diagram due to horizontal temperature rise. If there is a temperature rise, there I have given you alpha TL by integral of y square dx by EIC, something like that we have written. So this is the formula. So only horizontal thrust will be there. H is constant. This is H. At a section XX means Y. So bending moment at XX, you will get H into Y. H is constant, Y. Y is the parabola. Whatever way Y varies, the bending moment also varies. So in a two-hinged arch, the shape of BMD will correspond to the shape of the arch due to temperature rise. So correct. Shape of the arch. Y represents the shape of the arch. Next. What is the reason? Hinges at supports will exert only horizontal thrust on the supports. You see here, this is what I gave you in the class notes. Due to temperature rise, only horizontal thrust will develop, H into Y. So H is constant. Whatever way Y varies, bending moment also varies in the same way. So assertion is correct, reason is correct, and reason is the correct explanation for the assertion. So correct option is A. Next, 40th one. In a three-hinged arch subjected to uniformly distributed load over the span, with rise in temperature, horizontal thrust at supports will increase. Subjected to UDL and with rise in temperature. First UDL is there, then you heat it, then what will happen? Height will increase, horizontal thrust will decrease. The rise in temperature, horizontal thrust at supports will increase is wrong. Horizontal thrust at supports will decrease. That's what you have written in the conclusion statements also. So assertion is wrong. Reason, rise in temperature increases the length of the arch. Because the height increases, so length of the arch will increase. So this is A is false, but R is true. Rise in temperature increases the length of the arch, the curved length of the arch will increase slightly, but assertion is wrong. It will with rise in temperature, horizontal thrust at supports will decrease, okay, increases the length of the arch. So assertion A is false, R is true. So A is false, R is true means D is the option. 40th question, D is the option. Next, 41. Curved length increases length of the arch means this one, right? This is some H say. When you increase it, it will go here. This delta H I have given L square plus 4H square by 4H alpha into T. So now length of the arch increased, but horizontal thrust will decrease. H will decrease if it is already subjected to UDL. That's what we have written. So D is the correct one. Next, 41. In a parabolic symmetrical three-hinged arch, the bending moment at any section due to dead load is 0. That is correct, because due to dead load means uniformly distributed dead load. It's like UDL. So it follows the shape of BMD. So bending moment everywhere it is 0. Correct. Reason, the ILD for moment at any section in the arch, the simply supported moment diagram, that means AB by L, HY, that means LY by 4H, moment diagram have equal areas. That's why. So reason is correct, assertion is correct, and this is the correct explanation for that, because it follows that. 41 we can take A. Both statements are correct, and also explanation we can say the same thing, but actually the 300 parabolic arch bending moment at any section is means funicular polygon. That means if you build any arch which follows the shape of BMD, then it is called a linear arch, then cross section is subjected to only normal thrust. Such cases, if you draw ILD, you will get positive area and negative area balances. Okay, 41. 42. Shallow arches are undesirable. Shallow arches are undesirable because H is equal to WL square by 8H. Shallow means depth is less. If height is less, H will be more. Undesirable because you should have greater height, say horizontal thrust will be less. Correct. So shallow arches are undesirable. Next reason, heavy foundation support has to be designed to resist high value of horizontal thrust. Correct. You see here, now H will become WL square by 8H. If shallow arch H is less, though capital H will be more, then the foundation must be designed to resist greater thrust, otherwise it will fail. So assertion is correct, reason is correct, and reason is correct explanation for assertion. So shallow arches are undesirable, so A is the option. 42 is A. Next. Okay. Now we'll see the 43rd question. Any arch cannot practically be built to the shape of the theoretical arch. Correct? Why? The shape of the theoretical arch is affected by the loads moving on it. Reason is also correct. If the loads are moving, shape of the bending moment diagram changes. That means once you build one arch, theoretical arch, when the loads move, bending moment changes, but shape of the arch will not change. That means that you cannot practice. It means that any arch cannot be built in the shape of theoretical arch, because the loads are moving, bending moment also changes, but already built shape cannot change. So assertion is correct, reason is correct, and reason is the correct explanation for the assertion. So this is what I have told you. 43, assertion, reason correct, and explanation is also correct. That's why 43rd one is A. 44, a two-hinged arch compared to a simply supported beam of identical span and vertical loading develops lesser bending moment. Correct. Why? The arch resists the load by vertical as well as horizontal components of the support reactions. Vertical reaction will resist, horizontal thrust also will give moment H into Y. So assertion correct, reason correct, and explanation is also correct. So 44 is A. Then 45. For the frame shown in figure below, bending moment at every cross section is 0. They have given like this. This load is P. Load is P. Like this given, L by 4. This distance is L by 4, L by 2, L by 4. This is L by 2. L by 2, L by 4. That means this is theta. Let us say tan theta is equal to 2 by 1. You will get that theta is equal to tan inverse 2, something like that. Okay. Now, if you take the bending moment diagram shown in figure, bending moment at every cross section is 0, because the shape of the structure follows the funicular polygon. Now, for this one, funicular polygon means a simply supported beam, you take it, subjected to P here, L by 4, L by 4. What's the bending moment diagram you will get? This is P here, P here, P into L by 4. This is like this. This height is PL by 4, PL by 4. This is the shape of the BMD. Okay. Since it follows the shape of the bending moment diagram, bending moment at every cross section is 0. That means assertion is correct, reason is correct, and reason is correct explanation for the assertion. For that, supposing that it is a so we can take that assertion A, reason is correct, correct explanation. 45A follows the funicular polygon, means funicular polygon or shape of BMD both mean the same. Okay, then here he didn't give you the horizontal, whether it is a, it's like a cable. Okay, push it this way. 46. A two-hinged arch compared to a simply supported beam of identical span and vertical loading develops lesser bending moment, correct? So, this is also repeated one. 46. So, it is like a 44 only. So, assertion and reasoning are correct, explanation is also correct. Then 47. A three-hinged parabolic arch will not have bending moment due to uniformly distributed load throughout its length, correct? Because the vertical intercept between the linear arch and the center line of the actual arch gives bending moment at a section, correct? Due to uniformly distributed load, linear arch will be a parabola, correct? It will pass through the hinge at the crown, correct? The center line of the actual arch is parabolic, passing through the central hinge, correct? These two parabolas pass through three common points and hence overlap each other, correct? So, assertion, reason correct, and reason is the correct explanation for the assertion. So, 47 is A. It is like Eddy's theorem, he has repeated in a big story type thing, that is all. 48. Bending moment at any section of a three-hinged parabolic arch is the product of H and vertical intercept between the linear arch and the geometric arch. That is also correct, because Eddy's theorem, whatever intercept, the more the intercept, H into Y, the more is the bending moment you will get, and that is the bending moment at any section. H into vertical intercept in the theoretical arch and actual arch gives you the actual bending moment. Reason: vertical support reaction does not contribute bending moment at any section. This is not the explanation. Reason is false. Vertical support reaction contribute bending moment at any section. This is not the correct explanation for that. Eddy's theorem tells you that H into the intercept gives you the bending moment. The more is the difference, the more is the bending moment. In the process, vertical support reaction also contributes to the bending moment only. Okay, assertion is correct, but reason is false. That means A is correct, B is false, means C is the answer. 48C. 49. That means the Eddy's theorem gives you that way. The more the error between the linear and theoretical arches, the more is the bending moment. H into intercept gives you that. Then 49. Bending moment due to any load at all sections in the arch is less than bending moment at all sections of a simple beam having the same span of arch under the same load. Correct? Because the moment due to horizontal thrust of the arch is hogging. H into Y is a hogging moment. So assertion correct, reason correct, and reason is the correct explanation for assertion. So 49A. Then 50. Any arch cannot be built. This is also repeated one. So A is the option. Numerical data type questions. Segmental arch. This is nothing. Simply we have already solved earlier one problem. The same thing here also. Instead of one load, two loads are there. First 51, what we do is 2 meters, 4 meters. 3 hinge rods consisting of two quadrantal parts of AC, BC. This is one part, another part. A, C, B. 40 kilonewton, 60 kilonewton. This already I solved it. This from here, this is a center line, let us say. One question we have solved on this one. This radius is 2r. Let us say 4 meters. This radius is r. Let us say 2 meters. This angle of inclination is 45 degrees. Okay. So 2 meters to 45 degrees means somewhere it will cut here. We can find that. This is also 45 degrees. Okay. This point let us say O. 2. This is O1. Reactions are, you can take VA, HA, VB, HB. So first you take moments of all forces about B is equal to 0. Okay. Then how much you will get? Sigma MB is equal to 0 plus VA into this length is 2 meters. 2 plus 4 up to here 2, this is 4. So plus VA into 6 plus HA into 2, because this distance now will become only 2 meters. This is plus, this is also plus, but this is minus. Minus 40 into, from here to here 4. This distance 2 cos 45. 40 into 4 plus 2 cos 45. This is the distance. Minus 60 into this distance. How much is this? 4 minus 4 cos 45. 4 minus 4 cos 45. 0. So you will get one equation in terms of VA, HA. Then bending moment at C is equal to 0. Stand at C, look left. So you will get plus VA into 2 minus HA into 2 minus 40 into perpendicular distance is 2 cos 45, must be 0. So this is second equation. Solving 1 and 2, find VA and HA. This in terms of 2 meters, 4 meters given. Earlier it was R and 2R. One problem we solved, same thing, repetition. The bend moment at D. D is here. So once V and HA is known, bend moment at D is equal to stand at D and look left. How much you will get? Plus VA into here to here 2 minus 2 cos 45. VA into 2 minus 2 cos 45 plus minus HA into this perpendicular radius is 2. This height is 2 sin 45. This height. So minus HA into 2 sin 45. This is the bend moment at D. These are the expressions. Solve them. First equation, second equation, solve them. Find bend moment at D. Okay. Okay. 10 minutes break. Now we'll see the fourth chapter, methods of structural analysis. In that first point, the number of unknowns to be determined in the stiffness method is equal to kinematic indeterminacy. I told you that point in the class. How many equations are to be solved in the stiffness method or slope deflection method is dk. If kinematic indeterminacy is 10, 10 simultaneous equations you have to solve. Okay, next. Second one. Methods of indeterminate structural analysis may be grouped under either force method or displacement method. Which of the groups given below is correct? Force method. He has given moment distribution method, consistent deformation method. Moment distribution method is not force method, so A is wrong. Then B, method of three moments, consistent deformation. I told you method of three moments will take the compatibility method, means it is a force method called consistent deformation. B is correct, force method only. There is a moment distribution method, slope deflection method is given, that come under displacement method. So B 2 correctly matched. C, slope deflection method is given, consistent deformation, that's not correctly matched because slope deflection method comes under displacement method. So that is wrong. D, method of three moments is given, D is also wrong. So correctly matched was method of three moments, consistent deformation is force method, moment distribution, slope deflection, displacement method. So second question is B is the answer. Next, match the following methods with appropriate analysis. Strain energy is given, complementary energy, Muller principle, Carney's method. Okay. Now strain energy method. Strain energy method, I can use it for deflection of linear structures. Complementary energy method, deflection of non-linear structures. I told you complementary method we can find to use the deflections of linear as well as non-linear structures. But geometric non-linearity you cannot apply, but material non-linearity is there, we can apply complementary energy method. Okay, so B3 is matched, strain energy method, deflection of linear structures only, because that is what Castigliano's theorem 2 tells you, valid for linear elastic structures only. So A2 complementary energy method is applicable to non-linear structures. B3 Muller principle, influence for redundant structures. You can take redundant structures. Kani's method, analysis of multi-storied frames. So like this. Oh, we have to match like this only. A2, so A2, B3, C1, D4. This is what you have to write. Match the following means like that. Next, fourth one. That's why I have given you one full class on the strain energy methods, complementary energy method. Complementary strain energy method, Castigliano's theorem 1. Applicable to that strain energy method means dou u by dou p we have to write. Energy dou u by dou delta. If you write it, you will get the force. But another strain energy method, dou u by dou x, you will get the displacement. That if you have to use strain energy method means for the finding deflections, it must be linear elastic structures. That is Castigliano's theorem 2 belongs to strain energy method. Complementary energy method, Crotty-Engesar method, valid for linear, non-linear elastic structures to find the displacements. Okay, Muller we know, Kani's method also we know. You have a multi-storied frames say. Then first cycle, second cycle like that, rotation contribution, displacement contributions we take it. And regular classwork you have done many problems. Okay. So next fourth one. A single bay portal frame of height h fixed at the base is subjected to horizontal displacement at top. Base moments developed is proportional to. Like this is there. So if it sways to the top, we know it is 6EI delta by h square. So your moment MA is proportional to 1 by h square. Base moments are proportional to 1 by h square. So fourth one is B. Next, fifth question. A single bay, single story portal frame, single bay, single story portal frame has hinged left support, and fixed right support. It is loaded with UDL on the beam, Which one of the following statements is true with regards to the deformation of the frame? It sways to the left, sways to the right. If the loading is symmetrical, then whichever side column is weak flexurally, that means whichever column has less stiffness, in that side it sways. Compared to this is stiffness is 3I by L, flexural stiffness 4I by L. Since it is weak towards weak column side, so it sways to the left side. It would sway to the left side. So fifth question, A is the option. Sixth one, the magnitude of bending moment at the fixed support of the beam is equal to. This what is given. Load is P, support is here. This is A, B. Okay, cut here. This is equal to this one. This many problems we have solved, P and PA. And half of this is carried over. Moment at A is PA by 2. So PA by 2 means B is the option. This is called COM. Whether B is there, whatever length is there, it will not influence. Next, 7. Identify the correct deflection diagram corresponding to the loading in the plane frame shown below. There is a loading here. You see, now because this is the diagram, seventh question is like this. How we have to resolve is this way. This is the roller support and loading is at top. Some P is there, say. At this point you take say A, B, C. Here horizontal reaction is 0. So HA has to be 0 because there is no reaction here. If HA is 0, VA will be there. So it is axially loaded member. So it will not bend. See, all the three curves, they have shown bend. The curve that they didn't show bend in the vertical member is D. So D is the answer. So it, as a rigid body, it it will go straight because there is no bending moment. Now, like this it will go to maintain 90 degrees line, like this, right? So this point is C, C will go to C dash. This correct answer is D. A, B, C will go to C dash. That's how we have to resolve the issue in the exam. Hinge, no reaction. So HA has to be 0. If HA is 0, on this column bending moment is 0. So it is axially loaded member. That means it should remain straight. Then which one is remaining straight? Next, 8. The moments at the ends A and B of a beam AB where A is fixed, B is hinged. A is fixed, B is hinged. When end B sinks by an amount delta, this we know, sinks by an amount delta are given as, we know this one, 3 EI delta by L square, and here 0. So 3 EI delta by L square 0 means D. Ninth one, identify the false statement from the following pertaining to methods of structural analysis. False statement, you have to take it. Influence lines for stress resultants in beams can be drawn using Muller's principle. Correct. Moment distribution method is a force method. Wrong. B is the wrong one because it is a displacement method. It is a displacement method. Next. Principle of virtual displacements can be used to establish condition of equilibrium. Correct. Principle of virtual displacements will give you an additional equations of equilibrium. Okay. Correct method. Substitute frame method is not applicable to frames subjected to significant sway. Substitute frame method means an approximate method of the moment distribution method. If you have a multi-storied frame, say, any beam when you want to analyze, below the beam you will fix it, above the beam you fix it, because anyhow it is not swaying. So where the sway is not there, you will take only a substitute frame. Means only one beam, continuous beam, and columns you will take it. Only that, assuming that floor, whatever beam you have taken, above the floor all columns are fixed, below the beam all columns are fixed. That is the substitute frame method, an approximate method, valid when there are no side sway. Side sway is not there means you can assume that they are fixed ones and go for the moment distribution method. Okay, it is a approximate method. Substitute frame method means an approximate method of moment distribution for the frames. Okay, not applicable means correct. Next, so wrong answer is this one, because once you know the wrong answer, pick up other three statements, what they are, don't worry. Next, 10th question. Carry over factor CAB, we solved in the class. CAB, we got it as 1. Value of support moment M, solved in the class. We have a frame like this, hinge, one support and support, hinge here 20 kilonewton, 1 meter. So out of 20 this will take 10 into 1 10, here half will be gone, 5 kilonewton meter. Okay, so correct answer 11th question is 5 kilonewton meter, because out of 20 this beam will take 10 into 1 is 10, out of 10 5 will be carried over. Support moment M. So he has given clockwise direction, so you can write minus 5 kilonewton meter. 5 minus 5 or plus 5 kilonewton meter. Anything you write it, but more precisely he has given direction means minus 5 is more correct. Then you will know that no, it's clockwise only, so plus 5. Clockwise they have shown, so plus 5 kilonewton meter. This length is 3 meters, it will not influence in COM. Next, 12th question. A horizontal fixed beam AB of length L has uniform flexural rigidity. During loading, the right support A rotates through an angle theta clockwise. That means the deflected shape will go like this. It rotated by theta clockwise. What is the distance of the point of contraflexure from the left support? So when it moves clockwise, how much moment they might have applied? 4ei by L into theta. How much is carried over? 2ei by L into theta, right? Now this is a hogging moment. This is sagging moment, like this. Like this bending moment diagram. 4ei by L theta. This is 2ei by L theta. Then this is he is asking x, L minus x. So x by 2 is equal to L minus x by 4. So 4x or 2x we can write it. 2x is equal to L minus x. Push it left side. 3x is equal to L. So x is equal to L by 3. At a distance of L by 3, POC will happen. So 12th question, A is the answer. Next, 13th, portal frame is shown in figure. Theta B, theta C is given. Value of moment at B. So you write the slope deflection equation. What is the slope deflection equation? Value of moment at B. MB is equal to MF BC plus 2 EI by L into 2 theta B plus theta C minus 3 delta by L. Now you see, on the span BC there is no loading, so it is 0. 2 theta B has given 400 by EI, theta B is 400 by EI, okay. Theta C is also same, 400 by EI, okay. With respect to B, C is not sinking, he didn't give you any sinking, so delta is 0. So in this case MB you will get 2EI by L into 2 into 400 by EI. L is span is 10 meters, 2EI by 10 meters. Span has given 10 meters. For this 13th question, this is over already. Okay. Now we are dealing with the 13th question. For this 13th question, this is the problem. This I remove now. You don't require this one. For this 13th question, this is the problem. Hinge here, load here, P, A, B, C, D. Okay, 4 meters, 10 meters. So MBC, we want to find MBC. He is asking moment at BC or MBA, anything we can find. MFBC, no load, so fixed end moment is 0. 2A by L, theta B he has given, theta C same, and no sinking. So that's how it will come. So 2EI by 10 into 2 theta B means 400 by EI plus theta C 400 by EI. That's all. So 2 into 400 plus 400 means 3 into 400. So moment at B for the span BC is EI cancels out. So 2 by 10 means 1 by 5 into 3 into 400. Okay. So 5 into 5, 8. 80. 80 into 3, 240. So you will get MBC 240 kilonewton meter. So 13th question, 240 means B is the answer. Like that. Once theta B, theta C are known to us, I can use slope deflection equation to finish off quickly. Delta is 0, fixed end moment 0. You have 1 minute time. But the idea that we must use slope deflection method, even if we take 1 minute time to get that idea, still we can manage the problem in our stipulated another 1 minute time. Once you are given theta B, theta C, like slopes are given, say, think of slope deflection method to get out quickly. That means any fixed beam, if a support rotates by theta, let us say, then that means 4ai by L theta might have applied, and so carry over moment, half of that will go there, other end. Then from that you will know where is the point of inflection or point of contraflexure. Next, 14th question. 4 identical beams have been rigidly jointed at E. They are identical beams. Point C slips and rotates along with member firmly fixed at E. Okay, let us see what it is. Okay, 4 identical members. A, B, C, D, E. Okay, 4 identical members are there, have been rigidly jointed at E. Okay, the point C slips and rotates along with member firmly fixed at E. Slips and rotates along with member firmly fixed at E. So in this direction it rotates by an angle theta. So it rotated by theta, let us say. So this is theta. It slipped because fixed E could not maintain, it rotated. Which one among the following statements is correct? There is no moment on all members. You see, this rigidly jointed, when you apply moment here, you might have applied 4ei by L into theta. How much is carried over here? 2ei by L into theta. And this gets distributed to all members. So there is no moment on the all members is wrong. A statement is wrong. Except at C, there is no moment on the members of the frame. Except at C, there is no moment on the frame. B is also wrong, because this 2ei by L is distributed to all members, okay, in the ratio of their distribution factors. Okay, so second statement is wrong. Except at C and E for member EC, no moment will be there on other members. That is also wrong, because whatever member is there, halfway will be carried over. Everywhere COM will be there. All members are subjected to moment because COM comes. So D is the correct one. Once one member rotates, far end is also half the moment is carried over. If that is rigidly jointed, whatever carryover moment is there, it gets distributed to all the members. After distribution is over, half the moment is carried over to far ends. Okay, so all members are subjected to moments. Okay, next 15th. What is the horizontal sway of point A of the portal frame shown in the figure above? See here, this is problem we solved in the class. This point is L, EI is infinity, load is P. This is hinge support. When you put a circle, it is a hinge. So this is the deflection profile. Force required is 12 EI by L cube. Far end hinge, you require 3 EI by 12 EI delta by L cube, 3 EI delta by L cube. So P is equal to 15 EI delta by L cube. So sway means PL cube by 15 EI. These problems we solved in the class. PL cube by 15 EI. So 15 D is the option. 16. A horizontal fixed beam AB, fixed at both ends, at both its ends, A and B. During loading, the right support sinks by delta. Some process right support sinks by delta. delta. Flexural rigidity of the beam is uniform and equal to EI. Length of the beam is L. What is the moment developed at the center of the beam due to sinking of the support? Here anti-clockwise 6A delta by L square, 6A delta by L square will develop, right? Here also 6EI delta by L square. We have drawn the bend moment diagram also, hogging, sagging. What's the bend moment at center? 0. So 16, 0. So B is the option. 16th question, B is the option. Next, 17. A uniform simply supported beam is subjected to clockwise movement M at the left end. M at left end. What is the moment required at the right end so that the rotation of the right end is 0? Rotation of the right end 0, I want to get it. Because of this one, what I will get is, this is theta A, ml by 3ei. Here, this is anti-clockwise, theta B, ml by 6ei. Okay. Now, how much moment I have to apply so that slope becomes 0? Deflection profile will see. Now it behaves like a fixed one. This is M, already M is existing, A. If slope is to become 0 means, like this it will come. A simply supported beam, I want to apply MB. How much I have to apply so that slope becomes 0? If you apply moment M, slope becomes 0, then the deflection profile is like this. For it to become MB, how much we know? M by 2. That's all. Half of the moment we have to apply. So that right end 0 means M by 2. This is in the form of, it behaves like a COM. I told you, if you draw corresponding to theta 0 means deflection profile, if you draw, that deflection profile will tell you how much moment is required. This behaves now like a propped cantilever. Applied moment is M, half will be carried over to make the slope 0. So, M by 2. So, 17th question, you will get C. See, when you are this approximate, what is the chapter name? Methods of structural analysis. To answer this one, moment distribution method, slope deflection method, you again clearly read the notebook again, try to solve on your own, then listen to the lectures. You check whether what you have done is correct or wrong. That is the way. You must listen to these workbook solutions lectures especially. Otherwise, you will never understand, you will never get again chance to think on your own. There should be a day where you have to think on your own and check the result, means you are checking the result. Otherwise, you correct, but what we have understood, what we thought. The thought process is important. In the thought process, then you will know how many ways are there to make mistakes. Then you will know how to quickly get out of the problem in specified 30 seconds time. Okay, these are all the ways you see. I am reading the problem. Unfortunately, I am also reading for the first time. So, as the question I am reading, I am marking it. Then get the value. Okay. 17 is done with. Then 18. A beam AB fixed at both ends. So, simply you have to write that one, fixed at both ends. Carries uniformly distributed load per unit length over its entire length. How much is that? P kilonewtons per meter. Okay. Due to some constructional defect, and B is now reduced to simple support. Some problem came, it behaved like a simple support. This is P kilonewtons per meter. Okay. The end B is now reduced to simple support. The percentage increase in the bending moment at A. What is the bending moment at A in the first place here? MA, we know it is WL square by 12. Now for this case, MA is WL square by 8. Then how much bending moment increased? Percentage of increase. Percentage increase. Earlier it is WL square by 8 minus WL square by 12. Right? This is the increase for WL square by 12. So how much will get? 8 to 12 means 24 common, you can take it, 3, 2, 1. So WL square by 24 by WL square by 12. That means you will get 0.5. So 50%. So 50% increase. That means WL square by 12. You add 50% of that, WL square by 24. How much you will get? 24, 2, 3, 3 WL square by 24. That means WL square by 8. That means increase is 50%. So where is the 50%? So in percentage increase in the bending moment at A is 50%. So 18th, B is the answer. Next. So first, what is the question? Based on that, you sketch the diagram. Those diagrams, those deflection profiles will let you complete fast. So remember that no great thinking, no great calculations should be there when you are solving the problems. Next. 19. Slope deflection equations. Deformations are considered to be caused by, I told you slope deflection method, axial force, shear force neglected, only bending moment are considered. Shear force and bending moments wrong, axial shear force bending moment wrong, axial bending moment wrong, only bending moments correct. So 19D. A fixed beam with central point load, immediately draw that. Central point load W undergoes a slight settlement at one end. Slight settlement at one end. Delta. Select suitable answer from the following. Moment induced at both ends will be same. See here, due to W, what's the bending moment? MA. WL by 8. Right? Then fixed end moment also in the same direction due to sinking, plus 6 EI delta by L square. This is WL by 8. To make the slope 0, I'll show both. This is WL by 8 and this is 6 EI delta by L square. Here due to load clockwise movement, how much? WL by 8. Due to sinking, like this. To make the slope 0, 6 EI delta by L square. So moment at B you will get plus WL by 8. Both are opposite in nature, minus 6 EI delta by L square. So first option. Moment induced at both ends will be same. First option is wrong. B. Moment induced at the end that has undergone settlement will be maximum. Wrong, because subtraction was there. Moment induced will be maximum at the end having no settlement. C is correct. Zero moment at the end that has settled. Wrong. So 20th is C is the correct answer. Next 21 we solved in the class. So this is like this. Whatever problem has given, you make it like this. Fixed support, loading was there, W. The deflection profile will go something like this. If I take it this way, there is a pull VB, let us say 12 EI delta by L cubed is equal to W. So from this delta is WL cube by 12 EI. Now fixed end moment also will develop MB 6 EI delta by L square. So 6 EI delta means WL cube by 12 EI by L square. So you will get WL by 2. So 21 WL by 2. C is the answer. We solved in the class already. Then 22nd one. For the rigid frame shown below, what is the moment reaction at A? Moment reaction at A. See here, one end fixed, one end hinge. This length is 3 meters, this length is 4 meters. I. You are applying a moment of 40 kilonewton meter. I told you if the far end is hinge 3 meters, far end is fixed 4 meters, distribution factors are 0.5, 0.5. So this 40, after distribution it becomes 20. From here 0, no carry over moment. Here also it becomes 20. When you carry it over, 10 you will get. First distribute, then carry over. So 22 you will get 10. So 10 kilonewton meter is asking at A. So fix what is the moment reaction at A? 10. So that means, so 22nd question B is the answer. This much fast should be there. Far end hinge 3 meters, fix 4 meters. I told you 0.5, 0.5 distribution factors. So 40 gets distributed 20, 20. Out of 20, 0 here. This 20 out of here because it is fixed 10. Next, 23rd. What is the shear equation in the slope deflection method for the portal frame shown below? So these 3 diagrams we have to draw, I told you. P, it should not be kept on any free body diagram. This is MAB. This is MBA. Here MCD. This is MDC. Then the reactions. When you take clockwise or anti-clockwise, MAB plus MBA by L, clockwise or anti-clockwise, MCD plus MDC by L. So whatever MBA, these are the moments clockwise will be there. We are not interested. Horizontal shear equation means P HA HD. That means sigma x is equal to 0 means deals with external reactions. Plus P plus MAB plus MBA by L plus MCD plus MDC by L must be 0. So what he has given? MAB BA by L, BC CBB by, okay, B will remove it. C, MBC plus MCB, MCD DC. Okay, we will write now like this. MBA, this is what? Actually it is MBC. This is MCB. MCB is equal to, I can write minus MCD. This will become minus MBA. So MBA, if I write it as minus MBC, AB BA by L plus, okay, first option you see MAB plus MBA by L, MCD, MDC by L plus P is equal to 0. So you don't have to change this one. So 23rd, A is the option. Already A is given. Same equation he has given in the form of A. No question of transferring BA, MBA. We don't have to write it as minus MBC because option A matches with our equation itself. Next, 24. Frame. The frame below shows three beam elements. Okay, OA, OB, OC. OB is free hand, identical length, flexural rigidity, external moment M. The correct set of bending moments OA, OB, OC. Correct set of moments OA, OB, OC that develop at O in three beams respectively. See here, we should not solve entire problem and waste the time. Hinge, fixed, O, M, B, C. If far end is free, distribution factor is 0. So, moment at O for the member OB is 0. MOB 0. All 0 option is where? D. So directly D you answer without calculation. 10 seconds you should finish off. Once you know this, it should be 0. Then where is the 0? Only one option. Over. 25. The reaction at, okay, a two-span continuous beam have equal spans each of length L subjected to UDL per unit length. The beam has constant A. Reaction at the middle support. Reaction at the middle support. Bending moment at middle support. Two questions are given. So best thing is we take the MDM. Use MDM. Everything will be cleared quickly. You have joint A, B, C. Distribution factors. Here it is 1 because this is hinge support. Here 0.5, 0.5, 1. Fixed end moments minus WL square by 12 plus WL square by 12 minus WL square by 12 plus WL square by 12. Release plus WL square by 12 carry over moment plus WL square by 24. Here minus WL square by 12 after releasing minus WL square by 24. Now final moments. That story we don't have to write. 0 here. Then 24 means 24 common. 2 plus 1, 3. 3 WL square by 24. That means WL square by 8. So plus WL square by 8 naturally minus WL square by 8, 0. So WL square by 8, one of the options. Moment at the middle support WL square by 8. So 26th question we can answer directly B. Then 25th, what is the reaction at middle support? See, for that we'll write this one quickly. This moment is WL plus WL square by 8 minus WL square by 8 UDL. This here it is 0. Don't have to show unnecessary things because time is very less. First, due to load, this is W kilonewtons per meter. This box corresponds to A, VA, VB, VC. WL by 2 due to load. Due to moment some value, we are not interested. Due to load, WL by 2. Clockwise moment, so anti-clockwise couple. How much? WL square by M by L. That means WL by 8. This is upward, this is downward. This is upward, WL by 8. Okay, symmetry, WL by 2 up, and here anti-clockwise, so clockwise, WL by 8. WL by 8, here WL by 2 up. So center means middle support, WL by 2 plus WL by 2, WL. WL by 8 means you can write WL by 4. So 4 plus 1, 5 WL by 4. So 5 WL by 4. 25 question. C is the option. Here you don't have to write reaction due to supports, reaction due to end moment. I am applying principle of superposition. I am adding, kindly get the value like this. You don't have to explain to anyone to anything. How quickly you get out to this one is very important. When I gave you the free body diagrams, I assumed that you have learnt it for the first time. So entire story we have written. Now why upward, why downward, this also you don't have to explain to anyone. Quickly you manage that. 1 minute, maybe less than 1 minute, 2 questions you can close it. Next, 27. All members of the rigid jointed frame shown in figure prismatic same EI magnitude of bending moment at Q due to given loading. It's like this: fixed, hinge, fixed, P, T, R, Q. You have a clockwise moment of 100 kilonewton meter. This is 3 meters. This is 2 meters. This is 4 meters. This, yes, we are not interested. So 3, 4, 2. All EI same. Then in this case you have to write joint member K, K, sigma K. Distribution factors are K by sigma K. So joint T, TP. I by L means I by 3. This is TQ. I by 2. TR. I by 4. So all common factor when you want to take it, 3 into 6, 12 is enough. So 12 if I take the common factor, I by 3 into 4 I have to write. So 4I by 12. This 6I by 12. This 3I by 12. Right? So 4 plus 6, 10 plus 3, 13. 13I by 12. We wanted only this one, 6. 6 by 13. Distribution factor for TQ is 6 by 13. 6 by 13. He is asking what? Bending moment at Q. Okay, enough. 6 by 13. So moment at T for the member Q. You will get 100 into 6 by 13. You will get 600 by 13. Then moment at Q. Whatever MTQ is there here, half is transferred. MTQ by 2. So 600 by 13 divided by 2. That means 300 by 13 kilonewton meter. So 300 by 13. Oh, is fill in the blank. So 300 by 13 means 26, 40, 10. So approximately 23 0.26, 40, 39, then 1 will come, 0. So 100 means 23.07 kilonewton meter. So like that. Okay. This much speed should be there. All unnecessary things we will not calculate. Next, 28 question. A loaded portal frame shown in figure, the profile of its bend moment diagram will be. Let us see the 4 diagrams. Option A. On the column, there is a moment shown. On the beam, curved line shown, bend moment is 0. I told you at a rigid joint, if one member takes one moment, say anti-clockwise movement, say 10, another member clockwise 10 only should be there. Otherwise, joint will not be in equilibrium. So option A is wrong. Option B, with the same reason, wrong. Column there is a moment, beam 0 they have shown. That will not happen. C we can take, there is a, you see here, C point, there is a fixed end, but point of when far end is fixed, I told you if the far end is fixed due to COM concept, one moment will develop. That's why, but C, you see, option C, they have shown 0 bending moment at fixed support, which is impossible. So C is ruled out. Next, D, you see, because of COM, there is one point of contraflexure, correct. Then moment at the left corner, 2 moments they have shown, same magnitudes. UDL was there, diagram given. At the right end, there is a hinge, then bend moment is 0 they have shown. So all points satisfied. There is one point of contraflexure because of COM concept. Moments at the joints, 2 moments are equal on the beam and column at that joint. So with this condition, D is the option. Okay, that's how we have to manage the problem. 4 diagrams I am not drawing. I am thinking that you are having the question with you. So all of you must take the workbook. When we are dealing with 28 by 80, you have to see, or 28th question you must see. So drawing all the diagrams waste of time. 29. Find the ratio of the moments MBA and MCD induced at the column heads due to sway. Such cases, so I value has given infinity. This is the problem. EA is infinity. Okay. So IL, this is I by 2, L by 2. You are applying some load P. Then what's the deflection? I is infinity means it will go like this. Then MBA, you will get MBA is equal to 6 EI some delta by L square. Sway maybe some delta. Already this can be maintained like this only. This is fixed one. Will go like this. This is also delta. Then here moment is MCD. Because of the fixed T, 90 degrees will be maintained. This is 3 EI means I by 2. 3 EI delta by L square. L means L by 2 square. So you will get L square by 4 means 4 into 3, 12. Right? 12 into 2, 6. 6 EI delta by L square. So MBA by MCD. This is BA, CD. You will get 1. So this by that. So it should be 1. So 29D. These problems we have solved in the class also. Next 30. Carryover factor CAB for the beam shown in figure. Carryover factor solved in the class. D. (31). What is the rotation of the member at C for the frame shown in figure? This also we solved in the class. So M means M by 2, far end means ML by 12 EI. D. This is solved in the class. Next 32. In portal frame shown below, what are the distribution factors for members BA, BC, BD? BA, BC, BD. So only one thing they have asked, 32nd question. We have to find distribution factors. So joint member K, give some gap, sigma K, K by sigma K. Okay. Joint B we wanted. There are three members, BA, BC, BD. So B to A, I by L. 2I by 2L, that means I by L. BC, I by L. BD, I by L. So 3I by L. 1 by 3, 1 by 3, 1 by 3. So 32A, 33. The unit load method used in structural analysis is, whatever unit load method we have applied, applicable only to statically indeterminate structures. Not necessary. For determinate structures also we have applied unit load method to find the displacements. Another name for stiffness method, wrong. It is another name for force method. Wherever force methods we have taken, displacement produced due to unit load we have taken. So this is a unit load method, is a characteristic of force method. So not stiffness method. So B is wrong. An extension of Maxwell's reciprocal theorem. Reciprocal theorem is not an extension, unit load means. It will only tell you that load and displacement positions can be interchanged, need not be unit load. It is derived from Castigliano's theorem. That means Castigliano's theorem 2, we have to see. So what is the Castigliano's theorem 2? So delta, when you are writing sigma P KL by AE, actually K means dou P by dou W. That dou P by dou W we have removed, replaced it by K, which comes, the meaning of dou P by dou W is forces in all members due to unit load, where you want to find the forces, where you want to find the displacement. So it is derived from Castigliano's theorem 2. So he didn't mention that, but it is theorem 2. Right? I think that point is clear. 34. The discussion you have to remember, again we cannot write whatever I talked. You listen to me carefully. 34. For a linear elastic structural system, minimization of potential energy yields compatibility conditions, constitutive relations, equilibrium equations, strain displacement relations. Minimum potential energy means principle of minimum strain energy. Minimum strain energy comes from Castigliano's theorem 2. Theorem 2 gives you, means a special case of Castigliano's theorem 2. We call minimum potential energy, we use dou U by dou X is equal to 0. When you are differentiating strain energy with respect to force, you are getting the displacement, you get 0. That means dou U by dou X is equal to 0 is a compatibility condition. So from the principle of minimum strain energy, or from the principle of least work, or from the principle of minimum potential energy, you will get a set of compatibility conditions. That's what we have written also that point in the energy methods chapter. So potential energy, strain energy. Potential energy means loss of the energy due to external loads, which is nothing but strain energy stored in the structure. So gives you a set of compatibility conditions. So 34A. Put a minimum of potential energy. Next. Then the minimization of the energy with respect to displacement, we cannot call it as principle of minimum strain energy. Minimum strain energy means energy should be differentiated with respect to force. Then what you get is minimum strain energy. If strain energy is differentiated with respect to displacement, what you get is force. Then dou E by dou delta is equal to 0 will not give you minimization of potential energy or minimization of strain energy. Okay, then 35. Choose the correct option regarding the following figure. This is outdated, cannot be given in the exam. Comes from theorem of three moments. Theorem of three moments. And also a moment is given at different location. Then fixed end moments we have to get it. That means bend moment diagrams. What the conditions you get is like this. A, B, C. Then you are applying somewhere here a clockwise moment of 90 kilonewton meter. So bend moment diagram when you write it. So the bend moment diagram will go like this. Clockwise means here reaction in anti-clockwise, downward force is negative bend moment, down, up. This is the bend moment diagram. This is 1.2 meters, 1.8 meters. A, B, C, D you take it. Here it is fixed one. Okay. So no loading is there. Negative, positive. So for the span AB and BC, if you write it, theorem of three moments for AB and BC. Theorem of three moments tells you like this: MA into L1 plus 2MB into L1 plus L2 plus MC into L2 is equal to minus 6A1 x1 bar by L1 minus 6A2 x2 bar by L2. MA is 0, remove it. 2MB into L1 plus L2. L1 is 3 meters, total is 3 meters, this is 4 meters. L1 plus L2, 3 meters plus 4 meters plus MC into 4 is equal to minus 6 A1 x1 bar by L1. Now let us see if we can manage. 4 plus 3 7 into 2 14, 14 MB plus 4 MC is equal to that's minus 6 A1 x1 bar by L1. Let us see where any option matches. 14 MB plus 4C. So you make it 7 MB plus 2 MC is equal to minus 6 A1 x1 bar by L1 by 2. 7 MB plus 2 MC. Which one option is matching? 7 MB plus 2 MC. 7 MB plus 2 MC. B and D are there. B and D. Now 1 is 140.4 divided by 2 means 70.2. So we can conveniently answer it as B. 34B. Okay. So this is the process. Where you miss this one is A1 x1 bar. For this triangle area, x1 bar, area, x2 bar. So that's where it is MA into L1 to 6 A1 x1 bar means this area. From here you have to find the CG. If you want the exact value, CG is here. This is x1 bar. CG is here. Again x1 bar. Okay, net value calculate 6A1 x1 bar. You will get that value. I think sufficient guideline I have given you, you should manage. This comes from theorem of three moments. Next 36. 35 is over, 36. The cantilever beam shown in the figure has load P acting at points. You have a cantilever beam. Two loads are acting, P here, P here. P, P. This is at A, this is at B. This is L by 4. This should be 3L by 4. Okay, L by 3 only, let us assume. Maybe cantilever is a printing mistake. If one is L by 4, another is L by 3, some more length should be there. Okay, let it be. Acting at points A and B, the deflection at B is delta when the load at B is removed. This is P. It's a curve, straight line. This is delta. Only when one load is there, this is delta, B. Next, when the load at A is removed, now you are applying P here. Deflection at A will be Maxwell's reciprocal displacement theorem. If you apply load P here, displacement is delta. If you apply load P here, displacement must be, is a curved line. It has to be delta from Maxwell. So 36 delta C. Next 37. Okay, 37. There is a fixed beam. Bending moment at A for the beam shown in figure. E is 200 GPa. This is, you applied load P. Length is L. E is 200 GPa, 100 GPa. What is the bending moment at A? This point A, B, C shown in the beam. So, compatibility condition. Delta C is same. Assume that out of P, this fellow has taken P1. This is delta C. What is delta C? P1 into L cube by 3EI. Next, take this beam. P1, this P2 you take it, length is same. This deflection must be same. P2 L cube by 3. E means you have to take E by 2, I. So you will get P2 into L cube goes to here, 2P2 L cube by 3EI. Right? Next, we can say that delta C must be equal. So P1 L cube by 3EI must be equal to 2P2 L cube by 3EI. So that means you will get P1 is equal to 2P2. That means P1 plus 2P2 is equal to P. P1 plus 2, P1 is 2P2. So 2P2 plus P2. is equal to P. So P2 you will get P by 3. P1, naturally it should be 2P by 3. So P1 when you are calculating, it became 2P by 3. This will be P by 3. So that P1 will become 2P2. He is asking what is the moment at A. What is MA now? P1 into L. That means 2PL by 3. So MA you will get 2PL by 3. 37D is the option. So E I can take it as E by 2. Why I substitute the values? This is 200, 100. That means E by 2 is this one. Okay. 37. 38. This problem, fixed beam, support shields, what is the moment at B? This we solved in the class. This is how it is given. It yields and rotates, then it will come down like this. So this is delta is equal to L theta. Then this is MB. 3EI delta by L square. So you will get 3EI theta by L. So C solved in the class. Next, we'll see 39. Force method in structural analysis always ensures compatibility of deformation, equilibrium of forces, kinematically admissible strains, overall safety. I told you the force method gives you a set of compatibility conditions. It gives you a set of compatibility conditions. So it always ensures compatibility of deformations, whether deformations are compatible or not. So force method characteristic is that. So A. Equilibrium of forces is a characteristic of stiffness method. Next 40. For the semicircular two-hinged arch, we have a semicircular two-hinged arch shown in figure below. A moment of 50 ton centimeter is applied at B. You have applied a moment of 50 ton meter at B. Produces a displacement of 0.5 centimeters at A. So it displaces 0.5 centimeters. That means structure has gone something like this. Delta A is 0.5 centimeters. Due to M, this is the displacement. This is P system of forces. Next, if a concentrated load of 10 ton is applied at A, this is next system. A, this point we will keep it. Now you apply 10 ton. How much is that? 10 ton is applied at A. The rotation at B in the arch. This is how much it rotated. Theta B how much? Now Bette's work theorem. From reciprocal work theorem. Work done by P system is equal to work done by Q system. Q system of forces. Now work done by P system means only this is there. P system in rotating theta. 50 into theta. 50 ton meter into theta. You see, when you are applying M, load is not there here. Work done by this system is only this much, M into theta. Next must be equal to work done by Q system. In the Q system, only one load is there. Corresponding displacement is 0.5. Must be equal to 10 ton into 0.5 centimeters. This is 50 ton meter. This is ton meter. 0.5 centimeters means 0.5 into 10 to the power of minus 2 meters. 10 ton meters. Okay, like that. The dimensions must be compatible. So 50 into theta is equal to 10 into 5, 5 into 10 to the power of minus 2. So theta is equal to 5 into 10 to the power of minus 2 by 50. So cancels out 10 to the power of minus 3, 0.001 radian. So 0.001 radian means 0.000 10 to the power of minus 3. 1 into 10 to the power of minus 3 means 0.001 radian. So 0.001 radian means B is the option. Question number 40. This is reciprocal work theorem from Betti's reciprocal work theorem. Reciprocal work theorem I have given you in the matrix methods. Wherever they ask you one system of forces, see that. Then second system of forces. When you apply 10, this might have rotated like this. Okay. Then how much it rotated? This angle say theta b. So at A, in the P system of forces, at A there need not be any load. Due to this there is some displacement, enough. Due to this load there is a displacement here, there is a displacement here. So here 10 ton into corresponding displacement, here you have to take it. When you apply moment, corresponding rotation, here you have to take it. That is called reciprocal work theorem. Work done by P system of forces in doing the work in moving the displacements of Q system of forces. That is called reciprocal work. Okay. Next, 41. I think in strength of materials also, sir might have told you many questions on the reciprocal work theorem and Maxwell's reciprocal displacement theorem. Okay, this is one addition. Actually, it should have been in SM. They have given it here. Next, 41. Principle of superposition will hold good for the analysis of linear structural systems only. Correct? Linear structural systems with small deformations. Okay, let us see that small deformation what is missing. Next, second one. The first one will take it as correct one, though they didn't give you small deformation. Okay. Stress in a structural member due to several applied loads is the sum of the effects due to each such forces, correct? Applied one at a time. Only if the Hooke's law holds good. Only if the Hooke's law holds good means Hooke's law with small deformation. Okay, that means loads are applied within proportionality limit. So 2 is also correct, let us say. Internal stresses may not be caused resulting from lack of fit of a structural member. Resulting stresses may not be caused from lack of fit in a structural member. If the lack of fit is there, internal stresses may be caused, because if you take indeterminate structure, it will develop. So third statement is wrong. Internal stresses may be caused resulting from lack of fit of a structural member is given, say, may be caused. Then it will cover everything. If you have indeterminate structure, whether it is linear elastic or not, we don't have to worry. If it is indeterminate structure, internal stresses will be caused because of the lack of fit. So third statement is wrong. May not be caused means it will be caused if you take indeterminate structure. So third statement you cannot generalize. May not be caused means wrong. Only 1 and 2 are correct. 41b. Once he says may not be caused, it is only valid for determinate structures. Linear elastic, determinate structure, if given, may not be caused. But if it is linear elastic, indeterminate structure, internal stresses may be caused due to lack of fit. So that statement you cannot say. Okay. Next, 42. A fixed beam of uniform cross section is loaded throughout the span. Fixed beam loaded throughout the span. What is the proportion of the bending moment at the center to the end moment considering only elastic conditions? We know center WL square by 24. Here WL square by 12. Fixed beam subjected. We have done many diagrams. So bending moment at the center to the end moment. What is the proportion? Center is 24, 12. So 1 by 2. So 1 is to 2. So WL square by 12, 2 times of that is center, WL square by 24. So 42b. 43. What is the value of vertical reaction at A? This is the question. Hinge here, hinge here. Fix, hinge it, hinge it. A, B, C, D. This load is 10 kilonewtons per meter. He is asking what is the vertical reaction at A. So VA, this may be VD, HA, HD. Okay. What is the vertical reaction at A? So if I take, so we require the question once again. What is the vertical reaction at A? So which equation of equilibrium better? Bending moment at C is equal to 0. Lengths are same. This is 5 meters, 4 meters. So bending moment at C is equal to 0. First we'll write it. Plus VA into 5 minus HA into 4 is equal to 0. So stand here, look left. This is this one. So HA you will get 5 by 4 means 1.25 VA. 1 point. Then we can write bend moment at C is equal to 0. If I take it from the right side, I can get HD. Yes. Bending moment at C is equal to 0. Stand at C and look down. Stand here, look down. Minus HD into 4. This is clockwise movement. Plus 10 into 4 into 2 must be 0. So HD you will get, goes to the right side, 4 cancels, 20. So HD is 20 kilonewton. Okay. So once HD value is found, HD is 20. HA how much it should be? 10 into 440 means it has to be 20. What's the vertical reaction at A? VA is equal to HA by 1.25. HA is 20 by 1.25. So 1.25 means I can take 5 by 4, 20 by 5 by 4. So 80 by 5, 16. So VA is equal to 16. So 43, C is the option. 44. Propped cantilever AB carries a UDL. First diagram carries UDL throughout its length Q. In this condition, the end moment reaction is QL square by 8. We know that Q into L square by 8. Right. Now, what is the clockwise moment required at B? How much moment you have to apply at B? At B to make the slope of the deflection curve equal to 0. That means what? How much moment I have to apply so that deflection curve is 0. Now, what is the deflection curve? Like this. For this to happen, how much MB I have to apply? QL square by 12. If you apply QL square by 12 for this beam, this QL square by 8 now will become QL square by 12. Because once you apply this one, half will be carried over here. So QL square by 24, when you add it, this will become, this is the deflection profile. So you have to add QL square by 12. C. This again the same thing. How much moment you have to apply so that slope becomes 0? If slope becomes 0, what is the deflection profile? It's a non-deflection profile. For this profile, we know what are the fixed end moments. So much you apply, naturally slope will be 0. Next, 45. The fixed beam AB has hinge at C. AB, hinge at C. Load is P. At midspan. A concentrated P is applied at C. What is the fixed end moment at A? L by 2, L by 2. What is the fixed end moment MA? Because the structure is symmetrical, loading is symmetrical, means I values everything same, it will take only P by 2. This we know. When I values are different, then they won't take equally. Any one thing is missing, not symmetry is there, then you have to take P1, P2, compatibility condition, delta you have to take it. Delta is equal to same for both. In this case, symmetrical load will be shared by the two beams equally. So P by 2, L by 2. What's the moment? PL by 4. So this is PL by 4. 45C. 46. Bending moments at the joints B and C of the portal frame respectively. This we solved. This is P, P by 2, P by 2. Stand here, look at this one. It is like for us upward force. So upward force is positive bending moment plus PL by 2. This is clockwise, so anti-clockwise reaction will develop. So it will sag the beam plus PL by 2. Here you got minus PL by 2. Downward forces. So it will give negative bending moment. Downward. So plus PL by 2 minus PL by 2. This we solved in the class. Plus PL by 2 minus PL by 2. A. This is solved in class. Next 47. bending moment in the column. Already this also we solved it. 47, 100 kilonewton was there, hinges are there. So top horizontal member behaves like a link. So 100 will be shared by the two columns. So 50 only will come. 50 into 4, 200. So 47D. Solved in class. Where in approximate methods. Approximate methods chapter. Okay, 47 is over. Next, 48. Plane frame shown below analyzed, neglecting deformation. Okay. This question is like this. Hinge, roller, 7 meters, 5 meters. This is 10 kilonewtons per meter. A, B, C, D. EI value also has given 81,380 kilonewton meter square. Column AB carries axial force only. You see here, HD is 0. Naturally, HA should be 0. Once this force is 0, this is axial load only. No bending moment. Correct. First one is correct. Vertical deflection at the center of beam BC is 1 mm. Center, because it now behaves like a simply supported beam, it sways like this, it deflects. Right? This deflection we calculated in the class. What is that? Simply supported beam. 5 WL to the power of 4 by 384 EI. 5 into W. 10 kilonewtons per meter means 10 Newton mm. I am taking newtons per mm. Length. What is the length of the beam? 5 meters. Or if we take kilonewtons per meter as it is, let us say, because 10 kilonewtons per meter. Length is 5 meters. WL to the power of 4 by 384 EI. 81 380. So this you will get 50 into 25 into 25 by 384 into 81 380. Zero zero cancels out. Beam BC is 1 mm. See here 625 here. 625 into 5 by 384 into 8138. Will it be coming to 1? So is not equal to 0.001 meter. So second statement wrong. You don't have to calculate whether it is 1 or not, you have to see, that's all. So with reference to the above statements, which of the following applies? Both statements are true, wrong. 1 is true but 2 is false. So B is correct. That's why calculators are not permitted, means you only have to guess whether it is equal to 1 or not. Okay. Next, 49. This I think we have solved in the class. What is the horizontal reaction at support A? 49 is D. This is solved in the class. 50. Now you see, this is the deflection profile. One W is given, the deflection shape, it is like this, there is a rigid this one. Okay, one more thing was there here. This some roller was there, let us say. On this one, you have applied a load W, so that this went like this. This also went like this. How they will share? If you take only one beam, only on one means W by 2, other is W by 2. So it will come down like this, let us say. So W by 2, this force is V, some center point, let us say C, VC, is equal to W by 2 is equal to 12 EI delta by L cube. Okay, now let us see the question. Heavy weight attached to the rod can slide in a grooved support as shown. What is the equilibrium sliding distance delta? How much it will go down? So delta is equal to WL cube by 24 EI. WL cube by 24 EI. 50 C is the option. From this you should be able to get this one. W will be shared by two members. So one member will take W by 2. For this profile, we know it is 12 EI delta by L cube is the force required to pull it down. That value is W by 2 given. So delta. Such problems we solved in the class. So it's similar to that. Next, 51. What force is required for the displacement for displacing support C horizontally through a distance delta? Okay, now you have a member like this, 2 meters, 2 meters. A, B, C. How much force P you have to apply? 2 meters, 2 meters. So that it will move by delta. Okay, so delta C is equal to summation of, integral of mx m dx by EI, because flexural member it is. Now delta C we know it is delta, mx m we have to calculate. From that we can get P. This I remove. Now you see, free body diagram we will take it. When you apply P here, left side P forms anti-clockwise couple. So clockwise couple, P up, P down. So delta C, integral of mx m dx by EI. So member mx m dx by EI. First we take member AB. Mx, stand here at xx at a distance of x. So mx means P into x. upward forces, so plus P into X. If you apply 1, then 1 into X. So integral of 0 to 2 meters Px into X dx by EI. So P into X cube by 3. X means 2 cube by 3. P into 8 by 3EI. Then CB member. Take a section here at a distance of X. So plus P into X again. So plus 1 into X again. 0 to 2. Same term. So P into 8 by 3EI. X cube by 3 means 2 cube by 3. So 8 by 3. So total is delta C is 2 times 8P by 3EI is equal to, he is telling delta. So P is equal to 3EI delta by 16. So correct option is 3EI delta by 16. So C is the option. This question number 51. 51 C. (52) This we solved in the class 2m0 by 3. We got it as B. Solved in class. 53 EI is 0. If EI is 0, that means it is a weak beam. So PH cube by 3EI. This I told you in the class in the flexion. Approximate methods of analysis I have given. P EI is equal to 0. That means weak beam. The deflection profile will go like this. So he is asking, then the horizontal displacement of beam BC of the portal frame shown in figure given below is assumed to be 0. Then the horizontal displacement of the beam BC would be, then it will go like this only. This is delta he is asking. So P H cube by 3EI. EI 0 means it cannot take moment. It is weak beam, not cable. EI is equal to 0 means weak beam, not cable. So the deflection profile is like this. So delta. So force is P by 2 because both will share equally. P by 2 into H is H only. WL cube by 3EI. So PH cube by 6EI. PH cubed by 6EI. D is the option. This we solved in the class. When it is a weak beam, we have done. When it is a cable, we have done. When it is a heavy beam, we have done. So he says it is a weak beam. EI0 means weak beam. Then 54, one and fixed. Hinge 10. Load is not given, so it is 10 only, we have to take it. 10, 1 meter, 1 meter, 6 meters, 2i, 2i, 4 meter, whatever values they have given. So it is one end fixed. I can take a frame like this. Hinge, there is an anti-clockwise movement of 10 kilonewton meter. Here there is a clockwise movement of again 10 kilonewton meter. Loading is symmetrical. Now which side it sways? Whichever side column is weak, it sways to the right. Sways to the right. Loading is anti-clockwise, clockwise means when I fold it, this will sit on this one. So it is symmetrical loading only. But if the loading is symmetrical, then the frame will sway towards the weak column side. Weak column is this one, right side. So it sways to the right. Sways towards right. So 54B, 54th question, it sways towards the right. Next, 55. Force required to produce unit displacement. That means translation without rotation at either 1/3 point of a fixed beam of span L and uniform flexural rigidity. You have a fixed beam. Either 1/3 point means this is L by 3 to L by 3. A, B, C. You want to produce unit displacement without rotation. Like this, say, you fix it. This is for this member, we know how to rotate it. This is, I want delta is equal to 1. What is the force required? 12 EI delta by L cube, L by 3 cube. Now delta I wanted 1. The other member, without rotation, I want to give unit displacement like this. For this one, how much is required? 12 EI delta is 1 by L cube, 2L by 3 cube. Okay. Now this is a P1, this is a P2. So force P is equal to P1 plus P2. Why? Both beams you have to push it down by 1 unit. L by 3 means I can write it as 3 into 3, 9 into 3, 27. 12 into 27 into EI by L cube plus 2L by 3. 12 into 27 into EI by 8 L cube. So if I take it out to the top, 8 common factor will take it, 8 into 12 into 27 EI plus 12 into 27 EI by 8 L cube. This we can write 8 into 12 means 8 plus 1, 9 into 12 into 27 EI by 8 L cube. So 12 means I can write it as 4 3 4 2s. Then the options will be, where is that? 2L cube. See this entire thing here we got 2. 9 into 3, 27 into 27 must be 729, because you should get 2 here. So correct option is D, 55D. See, you don't have to evaluate everything. Once 2 comes in the denominator 2, only one option is there. So finish off that fast. Then 56. Clockwise moments are applied to both ends of a uniformly simply supported beam. M. Moments are applied at both ends of a simply supported beam. If the ratio of the rotation of the two ends is 2, that means this is M1, M2 you have to take it. If this is theta, this is 2 theta, let us say. Then the ratio of the applied moments will be, so M2 by M1 we can take it, theta 2 theta. Now I can take MAB is equal to MFAB 0, I will write first statement, MFAB plus 2 EI by L into 2 theta A plus theta B minus 3 delta by L, say this is 0. So I will get delta is also 0, 2 theta A, theta B, this is 2 theta, this is theta. So I will get 2 plus 1 3 into 2 6 EI by L. Okay, next MBA, this you call it as M1, moment at A. Then M2, MFAB 0, MFBA 0, I'll write statement, MFBA plus 2 EI by L, 2 theta B plus theta A minus 3 delta by L. Fixed end moment 0, delta is 0, 2 theta B, this is 2 theta, theta A is theta only. So you will get 2 plus 1 3 into 2. 2 times near end, 2 times near end means theta 4 theta plus 1 5, 5 into 2 10. 5 into 2 10. Then he is asking M2 by M1, that means 10 by 6, that means 5 by 3. M2 by M1, 5 by 3. Question number, okay, 56C.